We know the uh, proof of ds in polar coordinates. After that, we should know radius of curvature, because the previous video, please watch previous video watching before watching this video, because where we have proved how ds square is equal to dr square plus r square into d theta square. That is what requirement. Therefore, now what if suppose our basic aim is here, now coming, there is a polar curve is there, and uh, mm, point is p is equal to r and theta. I can say that the entire angle is theta plus theta and theta plus delta theta, and this angle is I can say that delta theta. The entire angle is theta plus delta theta. Now, as we whenever the point moves to the q, whatever the, I can say that if you draw tangent at this, what is the change of tangents direction? Or we can say what is the rate of change in the tangential direction with respect to movement along the curve we want. That is actually, if you reciprocal it, you can get radius of curvature. We want that is ds by d phi. It is a reciprocal of what? It is equal to reciprocal of curvature, but it is equal to the radius of curvature. We already studied in what is radius of curvature and how, what is the meaning of that, we already studied. So that I'll tell you, before watching this video you should watch the previous videos also. Now in order to find out this radius of curvature as a means what is the change in the tangential direction per unit change in the movement along the curve. At that point, p point, we need to find out. That is the, I can say that, definition of curvature. And if you reciprocal it, you can get radius of curvature. So totally we want to find out this one. Okay, now by, I can say that here s is a function of, again, see here, yes, whatever this arc length is a function of theta, and theta is a function of what? We can say theta is a function of phi here, because we can by exterior angle, but you can apply the chain rule here. The rho is equal to ds by d theta and d phi by d theta, you can write it there. We know that we, in the previous classes, we already studied how ds square is equal to dr square plus r square into d theta square. Now just divide it by this one, theta here. In order to find out ds by d theta, we know these things. Ds square is equal to dr square plus r square into d theta square. If you divide by d theta square, what we can get? Ds by d theta whole square into dr by d theta whole square into r square. This is one, we can say that. See here, whenever r1 means first order derivative is called dr by d theta, and second order derivative is dr square by d theta square. Okay, now we can say that finally ds by d theta is equal to r square plus r1. The first order derivative is called, this is r1 square raised to 1 by 2. Now, once I know this ds by d theta, in order to find radius of curvature, another one I should know d phi by d theta. We already know that phi is equal to theta, theta plus, sorry, psi is equal to theta plus phi. This is phi, not equal. Keep in mind, this is plus here. I think here very clear here. That is whatever the psi is equal to theta plus phi. Now, what we have studied, we want to find out ds by d theta here. Already, this is actually we want it, and rho is equal to ds by d theta the whole divided by d phi by d theta. Already know that ds square is equal to dr square plus r square into d theta square. Then ds by d theta is whole square is equal to dr by d theta whole square plus r square. Finally, we can get ds by d theta is equal to r square plus r1 square whole raised to 1 by 2. But we want d phi by d theta. We already know that psi is equal to, by exterior in the figure, I will tell you, psi is equal to phi plus theta. I will show that figure. This one, phi is equal to, this is theta, the entire angle is theta plus, by exterior property you can say that psi is equal to, in the initial or you can manage this one as also psi is equal to theta plus phi. Okay, therefore you can say that d phi by d theta is equal to 1 plus d psi by d theta is equal to 1 plus d phi by d theta. And already in the previous classes, tan phi is equal to r divided by r1. This is also, so as I told you in the first previous video, I already proved this one. Tan phi is equal to r by r1 here. R1 is nothing but the uh, dr by d theta. That is already told, already proved that tan phi is equal to r into d theta by dr. Now differentiating, because what we want to find out d phi by d theta, keep in mind. Okay, I already know that. Okay, now if you differentiate with respect to theta using quotient rule, we can get like this: second square phi into d phi by d theta is equal to, we can get final this result. Now after substituting this I can say that what we find out, because in order to find out d psi by d theta, we need to find out d phi by d theta. In order to find out d psi by d theta, we need to find out d phi by d theta. We are going to calculating d psi by d theta. D phi by d theta is equal to like this, and we want actually after I can say that this one simplification. Okay, from the step 3, we know that d psi by d psi is equal to theta plus phi. From the steps uh, 3, I will go into how this is equal to this one. I will show you. Wait a minute. Okay, from the step 3, we know that d psi by d theta is equal to 1. Now, we want to find out d phi by d theta, because in order to find out d psi by d theta, we need to find out d phi by d theta. We already know, already told you tan phi is equal to r divided by r1. And second, if you differentiate second square, we already know that second square phi is equal to 1 plus tan square phi. Therefore, it becomes 1 plus r by r1 whole square. And the second square phi, if you differentiate this one, what you can say that, what we have find out, second square phi we find out, which is equal to r1 square plus r square divided by r1 square. If you differentiate this one, we can get second square phi into d phi by d theta is equal to r1 square minus r2 is missing here, this is r1 square. It comes like this, and finally we can conclude that second square phi is already know that r1 square plus r1 r square divided by r1 square into d phi by d theta is equal to like this. I'm putting second square phi value, this value I'm putting here. Then finally we can find out d phi by d theta is equal to r1 square minus r2 divided by r1 square plus r square. Substitute back this d phi by d theta in this equation, we can get d psi by d theta is equal to this one, d psi by d and it is equal to r1 square plus r square plus r1 square minus r1 r2. Finally we can get final step is d phi by d theta is equal to r1 square plus 2 r1 square r square plus 2 r1 square minus r1 r into r2 divided by r1 square plus r square. For this we can find out d psi by d theta. Actually, now we find out this one. See here, the 5 edited. But what we actually want, we want this one, or radius of curvature. We already know that ds by d theta is this one, and d phi by ds by d theta is like this. ds by d theta is equal to r square plus r1 whole square raised to 1 by 2. And d psi by d theta, just we have find out this is the value of d psi by d theta. Now we need require rho is equal to, in the place of ds by d theta we can put this, and d psi by d theta we can put this. Now finally we can get the radius of curvature is equal to this. So this is how we can prove this. The things are very easy. Okay, these steps, after 3 steps, third step you should understand, this is coming after third step. Once we know that tan phi is equal to r divided by r1, if you then already we know the formula second square phi is equal to 1 plus tan square phi. And after this we have to find out uh, differentiating this tan phi is equal to second square phi into d phi by d theta is equal to, we have to use what formula, u by v formula can get here. And after knowing the I can say that second square formula we already know this one. Based on this, once if you substitute back into the second square, you can get d phi by d theta is like this. And we actually want d psi by d theta, and substitute back into this equation, you can get like this. After substituting the same, you can get final result like this, rho is equal to this one. Okay, thank you.